Welcome to my video today's video lessons. Right. In this video, I'm going to explain about the UPS and the servo stabilizer. In my previous videos, we discussed about the power electronic devices and what are the applications of the power electronic devices. One of the application of this power electronic device are UPS. Right. What is an UPS means? Uninterrupted power supply. An uninterrupted power see the name it is indicating that uninterrupted power supply. Generally we receive the power from the board, electricity board, that whenever if power losses means what are the appliances, what are the circuits we are using, they will be shut down, power will be off. Right, this is the if suppose if television is running, whenever the power is off means it goes off, the television will be goes off. Right, similarly if you consider the computer, personal computer, whatever maybe we are working on this computer, if the power loss means immediately everything the computer will be shuts down. It is a little bit it is not good for us. That means the information will be lost what we are doing till now. So for that we need to provide an additional device. Here we can use the device that is called UPS. The name itself, it is uninterruptible power supply. And that means it is providing the power supply without any interruptions. See, this is a device. It provides the power to the load whenever the input power's mains power loss. This is uninterruptible power supply. That means if there is an UPS for our personal computer means, though the main supply is off, this UPS immediately provides the power to the personal computer. With that, the system will not be shut down. This is the main function of the UPS. Right. This is generally this UPS is used to protect hardware such as computers, data centers, telecommunication equipment, or other electrical equipment. That means wherever we need to use this, we need to provide this uninterruptible powers. So in that cases we use this UPS. This is the function. It is an electronic system. It provides a continuous power, emergency power to a load when the input power source or mains power failures. Generally the common the common electric problems we will face is voltage spikes or sustained over voltage, momentary or sustained reduction in the input voltage sag, noise at high frequencies, oscillations, instability of the mains frequency, harmonic distortion. These all the problems we will get from the main supply what we receive. These all are overcome by this UPS. Right. See here the UPS is mainly classified into three types of UPS. It is classified into three types: online UPS, line interactive UPS, and standby UPS. The types of UPS it is three types: online UPS, line interactive UPS, and standby UPS. See, what is online UPS? Online UPS also called double conversion. Right. Online UPS. Right. That means there is a circuit here. Whatever may be the supply, online means the supply from the supply AC means there is a rectifier. It converts AC to DC and it charges the battery. The battery, and what the battery charging will be connected to the load with the inverter DC to AC. Right. And the line interactive UPS. What is line interactive UPS means? Line interactive UPS maintains the inverter in line and redirects the battery's DC current path whenever there is power fluctuations. That means, say it is initially it is from the mains power. Whenever there are fluctuations in this mains power, it redirects, it switches from the mains to the this line into battery DC current. That is line interactive UPS. And the third one is offline UPS or standby UPS. See, in this offline system, generally the load is powered directly from the mains supply input power, and only whenever this power is off, the main supply is not available, then it switches to the DC power, that is backup power. Generally this standby systems or these offline UPSs we can use in below 1K VA systems, that is generally we will use in home appliances like computers. See, this is a block diagram of offline UPS. If you see this, there are solid lines and the dotted lines. See, in the offline UPS, the load is directly connected to the mains, the suppressor and filter, and there is a transfer switch. The main action is with this transfer switch. You see, whenever this main supply is on, the switch is transfer switch is connected with the main supply to load. Whenever this main supply is not available, whenever it is off, out, this transfer switch immediately switches to this solid lines. That is, in the solid lines, what are the parts? AC DC rectifier, battery, and an inverter. That means this means there is a rectifier converts AC to DC and it charges the battery, and again there is an inverter, it takes the DC voltage from the battery, it converts that into the AC and it drives the connected load. This is the function of the offline UPS. That means in offline UPS, initially it is connected to the main supply. Whenever there is a power loss from the mains, then this transfer switch switches from the mains to this battery source, DC source. This is about the offline UPS. And what are the advantages, what are the disadvantages? Means the main advantages, it is a little bit less cost, but the disadvantages, it takes some time to switch from this main supply to this DC source. This is the disadvantage of this offline UPS. This offline UPS also called the standby UPS system, which can give the only the most basic features. Initially, it is connected to the AC mains. Primary source is a filtered AC mains. Whenever the power breakage occurs, this switch, the transfer switch, will set like the backup source. And next is the online UPS. See, the name itself, it is online. If you see this diagram, the main supply, after that there is a rectifier function is it converts AC to pulsating DC, and there is a battery. This battery continuously charges, and from the battery to the DC inverter, takes the input from the battery, charge DC, and it converts into the AC and it drives the AC signal to the load. That means, see here, in online UPS, always the battery, the load is always drives the this load is always through the DC source only. Whatever may, though the main supply is available or not, this load is always driven by this DC source in this online UPS. Means this rectifier always converts AC, whatever may be the supply we are receiving, it always converts AC to DC, battery continuously charges, and inverter converts DC to AC and it drives the load. Suppose if the main supply is not available, whatever may be the battery DC source available, that is chargeable voltage, that is that voltage drives the load. Online UPS. So what is the advantage? Means here there is no switching action, so there is that means there is no lapse of time, right? And what is the drawback here is the cost of the equipment is increasing, and the lifetime of the battery is reduces, because it is always charging and providing the source. That is the drawback of this online UPS, and the cost also increases in this case. compared to offline UPS. Online UPS double, this is also called double conversion method. See here, the AC input is converted to DC by rectifying process. It is stored in the rechargeable battery. This DC is converted into AC by the process of inversion and given to the load or equipment which is connected. And in this type of UPS, where electrical isolation is mandatory. Generally, it is providing here. See here, the main supply is not at all directly connected to the load. That means there is the battery is in between, and then the isolation between this main supply and the load is provided in this online UPS. The cost is high because the designing is required more additional circuits, running converters and cooling system is required. Line interactive UPS. The third one is a line interactive UPS. See here, this line interactive UPS, suppose the power is the mains power is available, but there are fluctuations in this mains power, so in that case, this line interactive UPS is useful. See, if you observe this block diagram, there is a changing transformer and there is a bidirectional converter. That means it converts AC to DC and it charges the battery, as well as this bidirectional converter converts DC to AC and it drives the load through the charging transformer and filter. That means, see, this is the main supply utility input. This is from the main supply consider, right? If there are the power whatever we are receiving from the mains is supply is good, in that the load is directly driven from the filter UPS output. Suppose there are any fluctuations in this main supply, in that case this tap changing transformer switches to this DC load. In that case, immediately this this bidirectional converter converts the charged DC into AC and it drives the load. This is the function of the line interactive UPS. See, generally it is used for small business and departmental servers and webs. This is more or less same as that of offline UPS. It is almost similar, but there is a difference. That difference is the tap changing transformer. This voltage regulation is done by this tap changing transformer by changing the tap depending on input voltage. That means based on the input voltage, this voltage regulation is done. That means any fluctuations means it immediately switches to the DC source. If the power supply what we are receiving is good, means it is directly connected to this. Additional filtering is provided in this UPS. There is another filtering circuit at the load. This is about the line interactive UPS. And what are the applications of UPS means? Generally we can find many applications. It is used in data centers, industries, telecommunications, hospitals, banks and insurances, some special generally where we can use means wherever we need continuous power supply, we can use this UPS. These are the about the applications of UPS and types of UPS. Right. Next one is the servo stabilizer. Right. We know the voltage regulator, and it provides a constant load without though there are variations in the input supply or at the load, the output will be constant. Right. Here the servo stabilizer. What is a servo stabilizer means? It is a closed loop system which serves to maintain a balanced 3 or single phase output voltage despite of fluctuations at the input. See here the voltage stabilizer is also providing a constant output though there are variations in the input. It provides, see, this servo stabilizer controlled servo stabilizer is a servo motor control system, stabilization system. The main element here is servo motor that performs optimum voltage supply using a buck boost transformer that capture voltage fluctuations from input and regulates current to the correct output. What is a servo stabilizer means? It is a servo motor stabilization system. It is performing optimum voltage supply with using a buck boost transformer. This transformer captures voltage fluctuations from the input, whatever the voltage fluctuations from the input, it reads those values and it regulates that current to the correct output. This is a function of the servo stabilizer. We will see how it is, what is the construction and how it is providing the correct output. See, this is the block diagram of the servo stabilizer. If you observe this block diagram, the main blocks here is toroidal auto transformer and the buck boost transformer. Second one is the, see, here it is toroidal auto transformer, buck boost transformer, and this is the motor and power control unit. This is the controlling unit. This is the output stage. There is a sensor. This is about the block diagram. See, the main stages is auto transformer, carbon brush. These brushes are for motor, and a servo motor for synchronizing, and the buck boost transformer and the controlling circuit, electronic circuit or power controlling circuit. These are the main blocks in the voltage servo stabilizer. See, auto transformer. What is the function of the auto transformer? Generally, it is the shape of it is rounded shape, toroidal shape. This auto transformer function is it increases or decreases the voltages which is fed to the buck boost transformer. That means this is the transformer. Generally, it is depending on the windings. It produces the voltage. So in this auto transformer, this can be controlled by increasing or decreasing the voltages. 50% of output voltage is increased or decreased by this auto transformer only. Auto transformer, right? Suppose that means if the input voltage is here only the 160 volts, but generally we need 230 volts. So this auto transformer increases this 160 to 190 volts, and remaining leftover voltage is improved by the buck boost transformer. Carbon brushes, and this is moving part. Generally it is fitted in the shaft to make contact with the dimmer, that is auto transformer. Carbon brush, that means to decrease this auto transformer is decreasing or increasing the voltage depending on the input voltage. See, this decreasing and increasing is done by with the variation of the windings of the auto transformer. There is a it is fitted in the shaft to make the contact with the dimmer. This carbon brushes makes the contact with the dimmer. If the input voltage variation is very frequent, there are more fluctuations in the input voltage, this carbon brush will erase early, and that means in the servo stabilizer, the lifetime of this carbon brush is depending on the receiving input voltages. There are more fluctuations always frequently means the lifetime of the brush will be lost during servo motor. See, the synchronizing motor, servo motor, it is the main part of the servo stabilizer. The name itself, it is servo motor and servo stabilizer. See, this motor rotates the arm connected on the dimmer or auto transformer based on the required output. That means this motor rotates in clockwise or anti-clockwise to vary the windings of the auto transformer according to the input voltage. That means this generally motor runs Servo motor is runs in clockwise or anti-clockwise directions. This whether it is clockwise or anti-clockwise is depending on the received input. This is the function of the servo motor. And a buck boost transformer, it is also a type of transformer. It makes the adjustments to the applied voltage to alternating current equipment. That means this generally the transformer means it has primary and secondary windings. So this that means whenever there is a variation in the primary winding means obviously the output secondary winding voltage also varies. So in this that means this buck boost transformer has the facility to make adjustments to the applied voltage to alternating current equipment. And the controlling circuit, electronic controlling circuit, power control, it is see the name itself, it is saying controlling circuit. There are a microprocessor and PCB boards. So it sends the signals, this microprocessor always it sends the signals to various parts of a stabilizer like motor and the dimmer, etc. So it works according to that signal, and it controls it sends the signals to get the desired output. This is about the function of the control circuit. That means it always monitors the output voltage and it gives the feedback to the servo motor whether to run it clockwise or anti-clockwise. Based on that, the windings in the auto transformer will be changed. That means the primary of the servo stabilizer voltage is mirroring means the secondary of the servo stabilizer also buck boost transformer also varies. With that, the output of the voltage also varies. Electronic circuit, power control circuit. Right. See, now we will see the construction of the servo stabilizer. Construction means if you see this block diagram, this is the auto transformer. Auto transformer. It is in toroidal shape. Toroidal shape. This is the buck boost transformer. See, in this buck boost transformer, the primary is connected. One is connected. One end of the primary is fixed, and the another winding is connected with the shaft to the toroidal transformer through motor. This is the secondary of the transformer, not a buck boost transformer to the load. See, there is a servo motor by running it clockwise or anti-clockwise, this shaft will be moved to increase or reduce the number of windings in the auto transformer. And there is a power controlling circuit, motor and power controlling circuit. This circuit senses the output, it measures the variations of the output, and it sends a signal to the motor to make the desired changes. This is about the construction of the servo stabilizer. Primary is connected to the primary of buck boost transformer is connected to the auto transformer windings. One end is fixed, one end is movable. It is connected to through motor. This is the construction of the servo stabilizer. Auto transformer, it has toroid shape and are connected between neutral. See what is the input for means, it is connected between the neutral point and phase of the input power supply. Whatever may be the main supply, that is auto transformer is connected to that. Buck boost transformer connected between mains input and output of the stabilizer of load terminals. One terminal of primary buck boost is permanently connected to the fixing tapping of auto transformer, and other end is connected to motor shaft. Motor, one end of primary of connected to shaft of the motor with arm and brush mechanism. Motor is generally AC synchronous motor or DC servo motor. Generally it is a servo motor which is connected and fitted on top of auto transformer center point. Motor drivers for the motor, purely electronic circuit. Generally it has PCBs to drive the motor. It is consisting of solid state circuitry. It has a microprocessor and some more ICs. It is a controlling circuit. This is control circuit of power supply. PCB board needs constant DC power supply. Control circuitry PCB boards are needed. It means available power for PCB boards. It consists of rectifiers also to convert AC to DC and step down transformer. Operation of the servo stabilizer. See now what is the how it is providing the constant output, though there are variations in the input supply means just now we saw the construction. The supply is connected to the auto transformer and to the servo stabilizer also. Main supply secondary of the servo stabilizer connected to the main supply and load. See from the load, this the control circuitry monitors the load, reads the load, senses the load. This load that means whenever there is the variation in the output, whatever that means we are not receiving the desired output means this control circuitry provides sends a signal to the motor to run either clockwise or anti-clockwise. This depending on the motor movements, motor shaft movement, the number of windings in the auto transformer are reduced or increased. Suppose it is increased, the number of windings in the auto transformer are increased. That means the primary voltage of the buck boost transformer is increased. When the primary of the buck boost transformer voltage is increased means the induced voltage of the secondary of buck boost transformer also induces. That means the output voltage also increases. So this is the function of the servo stabilizer. See, based on the amount of high voltage or low voltage absorbed at input, motor driver moves servo motor across winding of the auto transformer so as to increase or decrease number of windings. Hence, voltage across primary of buck boost transformer changes. So this primary motor shaft is connected to primary of. When there is a change in voltage across primary of buck boost transformer means induced voltage across its secondary also changes. The motor moves in such a way that proper voltage should be observed across primary of buck boost transformer. Here the main function how we are getting the desired voltage, output voltage means depending on the movement of the motor shaft on the auto transformer windings. Based on this only, the voltage across primary of the buck boost transformer is changing. With that changed primary voltage, the induced voltage across its secondary of the buck boost transformer also changes. It is changing. This is the here the main function of this servo stabilizer, how it is providing means the control circuitry, it always senses the output and it compares the desired value with the received value and it sends a signal to the servo motor either to move clockwise or anti-clockwise, that means to decrease or increase the windings. Based on the decreased or increased windings in the auto transformer, that is toroidal transformer, the voltage induced in the primary of the servo motor varies. When the primary voltage of the transformer is varying means the induced voltage in the secondary is also varying. That means the output voltage is varying. This is the function of the servo stabilizer, right? And what are the applications of the servo stabilizer means generally the servo stabilizer is also providing the constant output voltages where we can use what are the applications means generally it is used for printing machines, medical equipments or medical machines, textiles. In the textile department also this can be used, CNC machines. That means for at high voltages we can use this servo stabilizer to provide the constant output, though there are fluctuations in the input. Generally this UPS also providing the constant voltage and servo stabilizer is also providing the constant voltage, but UPS is generally used for less than 1 kVA applications, and when that means and servo stabilizer used for higher kVA applications. This is the function of the UPS and servo stabilizers. See here that means depending on the application and where we need to use, we have to choose the UPS or servo stabilizer to provide the constant output voltage, though there are fluctuations in the that means without interrupting the power to the loads. Right, this is about servo stabilizer and UPS. So what are the questions we can expect from this means, we can, what is an UPS, types of UPS, that means in short answers, what is a servo stabilizer, we can expect in the short answers. So long answers, explain about offline UPS or online UPS or line interactive UPS, or sometimes explain all UPS systems. That is from the UPS topic. In the from the servo stabilizer, we can expect what is a servo stabilizer, draw the block diagram of the servo stabilizer, and what are the blocks in the servo stabilizer, main blocks in the servo stabilizer, or else sometimes explain servo stabilizer with block diagram. You can expect this question in long answers. Sometimes they may ask applications of servo stabilizer or UPS. These are the questions we can expect from this UPS and servo stabilizer systems. This is okay. With this, I am going to end my session. So, final. Thank you.